If you are watching this video, you are likely starting a chemistry course or chemistry subject. Get ready for a fantastic journey through a world of wonder, delight, and knowledge. One of the themes in this subject is chemistry is everywhere. And indeed, it is. You would not be alive if it weren't for chemistry. Your body is a big chemical machine. If you don't believe it, don't you worry. Every chapter in this subject contains examples that will show you how chemistry is, in fact, everywhere. So enjoy the ride and enjoy chemistry. So now, what is chemistry? Simply put, that chemistry is a study of interaction of matter with other matter and with energy. This seems straightforward enough. However, the definition of chemistry includes a wide range of topics that must be understood to gain a mastery of the whole subject or even take an additional courses in chemistry. In this subject, we will lay down the foundation of chemistry in a topic by topic fashion to provide you with the background you need to successfully understand chemistry for engineers. So before we dive into the concepts of chemistry, let us first have some sort of review and the definitions we have to understand first before taking chemistry. So again, the definition of chemistry states that it is a study of interaction of matter with other matter and with energy. It uses some terms that should also be defined. We start the study of chemistry by defining some basic terms. First, matter. A book is a matter. A computer is matter. Food is matter. Dirt in the ground is also matter. Sometimes matter may be difficult to identify. For example, air is matter, but because it is so thin compared to other matter, or it is invisible compared to them, that is, for example, a book, a computer, a food, a dirt as what we mentioned. So we sometimes forget that air has mass and takes up space. Things that are not matter include thoughts, ideas, emotions, and hopes. So now let us identify which of the following could we consider matter or not. So we have a cupcake, love, and tree. Which of this can we consider matter? Okay, a cupcake has mass and it also takes up space. So we could consider this matter. Next one, we have love. Love is an emotion, and emotions are not matter. Next, we have a tree. A tree has mass and takes up space, so we could consider it matter. So for us to know if you have already understand the concept of matter, which of the two is matter and which is not. Okay, the first one, we have the moon, and we have an idea for a new invention. Correct, the moon is matter. The invention itself may be matter, but the idea for it is not. To understand matter and how it changes, we need to be able to describe matter. There are two basic ways to describe matter: physical properties and chemical properties. Physical properties are characteristics that describe matter as it exists. Some of the many physical characteristics of matters are shape, color, size, temperature. An important physical property is the phase or the state of matter. The three fundamental phases of matters that we have already knew in our previous chemistry subjects or our science subjects in senior high school or in our junior high school are solid, liquid, and we have also gas. Chemical properties are characteristics of matter that describes how matter changes form in the presence of other matter. Does a sample of matter burn? Burning is a chemical property. Does it behave violently when put in water? This reaction is a chemical process, exhibiting chemical property as well. In the next chapters, we will see how the description of physical and chemical properties are important aspects of chemistry. Just take note that if matter always stayed the same, chemistry would be boring. Fortunately, the major part of chemistry involves change. A physical change occurs when a sample of matter changes one or more of its physical properties. For example, a solid may melt, or alcohol in the thermometer may change volume as the temperature changes. A physical change does not affect the chemical composition of matter. A chemical change is the process of demonstrating the chemical property, such as burning. As the matter in the match burns, for example, its chemical composition changes and a new form of matter with new physical properties are created. Note that the chemical changes are frequently accompanied by a physical change also, as the new matter will likely have different physical properties from the original matter. So now let us describe each of the process here as either physical change or a chemical change. Number 1, water and air turns into snow. Next, we have a person's hair is cut. Bread dough becomes fresh bread in an oven. So let us identify which of these three is a physical and which is undergoing a chemical change. Number 1, because the water is going from gas phase to solid phase. This is a physical change. Your long hair is being shortened. This is physical change. Next, we have the bread dough becoming fresh bread in an oven. Because of the oven's temperature, chemical changes are occurring in the bread dough to make it a fresh bread. Thus, there are chemical changes that had happened. In fact, a lot of cooking involves chemical changes. So now let us identify its process as a physical change or either chemical change. First, a fire is raging in a fireplace. Next, water is warmed to make a cup of tea. Okay, so correct for the first one is undergoing a chemical change. And for the second one is undergoing a physical change. So now let us recall some of the important parameters or concepts we have to understand in the field of chemistry. A sample of matter that has the same physical and chemical properties throughout is called a substance. Sometimes the phrase pure substance is used, but the word pure isn't needed. The definition of the term substance is an example of how chemistry has a specific definition for a word that is used in our everyday language with a different figure language. Here, we will use the term substance with its strict chemical definition. Chemistry recognizes two different types of substance. We have elements and we have compounds. An element is the simplest type of chemical substance. It cannot be broken down into simpler substance by ordinary chemical means. There are about 115 elements known to science, of which 80 are stable. The other elements are radioactive, a condition that we are going to consider when we have to understand and to discuss nuclear chemistry later on. Each element has its own unique set of physical and chemical properties. Examples of elements include iron, carbon, and we have also gold. A compound is a combination of more than one element. The physical and the chemical properties of a compound are different from the physical and chemical properties of its constituent elements. That is, it behaves as a completely different substance. There are over 50 million compounds known, and more are being discovered daily. Example of the compounds includes, for example, water. We have also some penicillin, sodium chloride, which is the chemical name for the common table salt that we use. Elements and compounds are not the only ways in which matter can be present. We frequently encounter objects that are physical combinations of more than one element or compound. Physical combinations of more than one substance are called mixtures. There are two types of mixtures. First, we have heterogeneous mixture, which is a mixture composed of two or more substances. It is easy to tell, sometimes by the naked eye, that more than one substance is present. A homogeneous mixture is a combination of two or more substances that is so intimately mixed that the mixture behaves as a single substance. Another word for a homogeneous mixture is a solution. Thus, a combination of salt and steel wool is a heterogeneous mixture because it is easy to see which of the particles of matter are salt crystals and which are steel wool. On the other hand, if you take salt crystals and dissolve them in water, it is very difficult to tell that you have more than one substance present just by looking. Even if you use a powerful microscope, the salt dissolved in water is a homogeneous mixture or a solution. Identify the following combinations as heterogeneous mixture or homogeneous mixture. Because carbon dioxide is dissolved in water, we can infer from the behavior of the salt crystals dissolved in water that carbon dioxide dissolved in water is also a homogeneous mixture. Next, a mixture of iron metal filings and sulfur powder. Both iron and sulfur are elements. Assuming that the iron and sulfur are simply mixed together, it should be easy to see what is iron and what is sulfur. So this is a heterogeneous mixture. Now, let us examine each of the following combinations as either homogeneous mixture or a heterogeneous mixture. Number one, your human body. Next, we have an amalgam, a combination of some other metals dissolved in a small amount of mercury. Your human body is a heterogeneous mixture. For example, you could see a blood and other forms of matter which we could easily identify. So it is a heterogeneous mixture. On the other hand, the amalgam is the combination of metals dissolved in the small amount of mercury that already became a homogeneous mixture. There are other descriptors that we can use to describe matter, especially elements. We can usually divide elements into metals and nonmetals, and each set shares certain properties. A metal is an element that is solid at room temperature, although mercury is a well-known exception. Metal is a shiny, silvery, that conducts electricity and heat well. It can be pounded into thin sheets, which is a property called malleability, and can be drawn also into thin wires, property we call as ductility. A non-metal, however, is an element that is brittle when solid. Does it conduct electricity or heat very well? A non-metal, however, is an element that is brittle when solid, does not conduct electricity and heat well, and cannot be made into thin wires or sheets. Non-metals also exist in variety of phases and colors at room temperatures. Some elements have properties of both metals and nonmetals and are called semi-metals, or for electronics term, it was used as metalloids. So we will see later how these descriptions can be assigned rather easily to various elements.
As what I have said a while ago, is that one of the discussion we have to emphasize is that chemistry is everywhere. So let us take a small specific example from your everyday activities. Let's consider your morning rituals. Most people have a morning ritual, a process that they go through every morning to get ready for the day. Chemistry appears in many of these activities.
If you take a shower or bath in the morning, you probably use soap, shampoo, or both. These items contains chemicals that interacts with oil and dirt on your body and hair to remove them and wash them away. Many of these products also contain chemicals that make you smell good, and they are called fragrances. When you brush your teeth in the morning, you usually use toothpaste, a form of soap to clean your teeth. Toothpastes typically contain tiny hard particles called abrasives that physically scrub your teeth. Many toothpastes also contain fluoride, a substance that chemically interacts with the surface of your teeth to help prevent cavities. Perhaps some take vitamins, supplements, or medicines every morning. Vitamins and other supplements contains chemicals that your body needs in small amounts to function properly. Medicines are chemicals that help combat diseases and promote health. Perhaps you make some fried eggs for breakfast. Frying eggs involves heating them enough so that the chemical reactions occurs to cook the egg. Then after you eat, the food in your stomach is chemically reacted so that the body, mostly your inner parts, can absorb food, water, and other nutrients. Next, if you drive or take a bus to school or to work, you are using a vehicle that probably burns gasoline, a material that burns fairly easily and provides energy to power the vehicle. Recall that burning is a chemical change. These are just a few examples of how chemistry impacts your everyday life. And take note, we haven't even made it to lunch yet. And I do hope that this one inspires you to learn chemistry. Because indeed, chemistry is everywhere. Chemistry is part of our life. And chemistry will be part of you being future engineers.